This is Britt Caswell with another example video. In today's video, I'm covering example 5 from section 6-3 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to solve equations with logarithms. So notice when I go to find this, I'm actually solving to the nearest thousandth. I'm going to be showing you how to get the exact answer as well as the rounded answer, only because many standardized tests still require you to find the exact answer. So for part A here, we have an exponential equation where our variable is part of the exponent for 10. So to take that variable out of the exponent, I'm actually going to take the logarithm of each side of the equation. Now when I take a logarithm, I need to be very aware of what base I'm using. Alright, so the base that I choose for my logarithm has to be whatever base I have for the exponential that I'm trying to undo. Okay, so since the x is with the 10, I'm taking a common log of base 10, not a log base 25. Okay, so here we go. So I have the log of 25 is equal to, the log and the 10 cancel out, and I'm left with x plus 1. Or I'm sorry, that says x minus 1. Ooh, don't make that goof. And so now to get rid of that minus 1, I'm going to add 1 to each side. Now when I add or subtract from a logarithm, I usually like to put it out in front, because often it's hard to see whether it's incorporated in that logarithm unless you use parentheses. Okay? So this is the exact solution. All right? Notice that that logarithm can't be broken down into an exact answer. If that had been like the log of 100, then I would have needed to simplify the logarithm. So now to approximate the answer, what I'm going to do is I'm going to find that logarithm of 25 first, and then add 1 to it. And so my answer for this, to the nearest thousandth, is 3 decimals, just so you know. I'm going to get x is approximately 2.398. So these are our two solutions. So now for B, we have a variable stuck inside of a logarithm. So when you have a variable stuck inside of a logarithm, you need to do a process called exponentiating. When we exponentiate, what we're doing is we are taking each side of the equation and raising it to some power. Well, raising it as the exponent of a power. I guess I should say it that way. So, for example, the base of the logarithm here, because it's a natural log, is e. So I'm taking both sides of the equation and raising them to become powers of e. So on the left-hand side, the e and the natural log cancel each other out, and I'm left with 2x plus 3. And on the right-hand side, I'm left with e to the 4th. Now, you're going to be tempted to put that into a calculator right away. You want to hold on until the end of the problem, okay? Because if you round in the middle, you're not going to get this precise of a solution that you're looking for, okay? So I'm subtracting 3, because that's our first step in getting x alone. And then 2 and x are multiplied, so I'm going to divide by 2 to get rid of it. So if I was asked for the exact solution, this is the exact solution. Okay. Now the approximation, I'm going into my calculator, I'm raising e to the 4th. It's about 54 if you're doing it with me. I'm subtracting 3 to get about 51 and dividing by 2. So x is approximately 25.799. So now on this one, again, we have a variable stuck inside of a logarithm, so we're still going to need to exponentiate. So I need to look at the base of that log and figure out what base I want for my exponent. So because they don't write a number here on the common log, that means it's common, so the base is 10. So I'm saying 10 to this exponent and 10 to this exponent. So on the left-hand side, the 10 and the log cancel out, and I'm left with 3x minus 2. And on the right-hand side, 10 squared is 100. Now this problem just kind of shakes itself out, right? So I add 2 to undo the subtraction. And when I divide by 3, I get a very nice 34. So this is both the exact solution and the approximate, because it's a whole number. You don't have to plug into a calculator or round or anything. All right, so one last problem. So now I have e raised to an exponent, and my variable is in that exponent. So what I have to do is take the log of each side to counteract that e. Now remember, if it's an e, the type of logarithm that I'm taking is the natural log, ln. So the natural log of e cancels out, and I'm left with x plus 2. And then I have the natural log of 8 over here. Then subtract 2 from each side to get x alone. So this here is the exact solution. And so now I'm going to go in and find the approximate. So I'm going to go ahead and find the natural log of 8, which is about 2.08, and then subtract 2 from it. So x is approximately 0.079, like that. So there we have it, guys. That is how to solve equations with logarithms. Until next time.